Hi guys, thanks to Rye for filming this. I just think that this is going to be easier than me writing out something that I know you won't read, because you're not that type of person that's going to read a long paper, are you? So I thought about that, and Rye offered to do this for me, so I appreciate that. So what I'm going to do is I'm going to go through the 4 lessons that we have for this week. And then next week I'll go through the 5 lessons that we have, because remember we had a lesson yesterday. And then whatever the 3 weeks are, the 14 days, I'll do the lessons this way, so that you can see how they're done. Because like I said, I know you don't want to read a paper, and I don't blame you. All right, so we're on lesson 120 here. So you need to read these chapters like I told you in class. Read them. Understand them, because this is stuff I really can't teach you, because they're right there in the book, and these are things you have to remember. So it's up to you to remember things, not me. So let's just go through this. Let's look at the left side here first. It's talking about the different types of triangles and what makes them what they are. Well, this top one's called an equilateral triangle, and the reason, just the word equals in there, right guys? So that right there tells you that each of the sides are the same. Now in the book it doesn't have any measurements there, but I put them there because you can see that they're all 3 centimeters. They're all the same. Equilateral. You should be able to remember that one pretty easy. The next one's just fun to say. Isosceles. Isosceles. All that is it's got 2 different sides that are the same length. The third one's not going to be the same. So you're going to have to use your ability to, size things up either with a ruler or just by sight, and you can usually see if 2 things are equal, right? So, and you'll see that one line is longer than the other 2. That's an isosceles triangle. Again, fun to say, not hard to remember really. The last one is called a scalene triangle, and nothing's equal. So that's pretty easy too. Just remember scalenes. Nothing's right with that thing. Nothing equals itself. So they're all different. Every one of them, if you can see down here, they're all different. Okay, so that's on page 583. That's lesson 120. The next half of that, I've already done half the lesson. So the next part of this is the triangles classified by the angles that are in them. So if we go over to this right page over here, you have a acute triangle. And you're going to have these kind of questions in your papers and everything, in your homework. So how are you going to know that that's an acute triangle? Remember what I said. I showed you, you know what a right angle is. You know that a right angle is always 90 degrees. So an acute triangle, you can say it's cute, so it's going to be smaller and everything. It's going to be smaller than that 90 degrees. Okay? So just look at that, and this, you see the way this is positioned? If you were to take that protractor, and I just showed you the protractor quickly on Monday, but if I were to put that protractor right there, Merv, where's your protractor? Can you believe it? I'm in the same house with Merv. I know. Okay, get out of here, Merv. Nothing changes. Okay, so here's the protractor. And I'm going to put that dot on there. Actually, there's a line right there. And see how this line is going to the right from that point right there? And see how on this one, everything's going to the left? If I were to put that point there, I'll explain that as we go through here. So I'm going to put that point right there and line that up. And remember, this line right down here is always 180 degrees. Okay? So, well, let's go down to this right angle here, right there. Because that's a better one. So that's 90 degrees right there. And anything, if that line is going to the right, it's going to be less than 90 degrees, right? So when you look at this top one here, I hate how this thing doesn't up. Bend out. Okay. So when you look at this top one here, it doesn't matter where you were to position this. That angle, that line right there, this one up here, the top one, is less than 90 degrees, right? And if I were to take this and use that corner and put that like this, that line is also less than 90 degrees. And the same is true if I were to go to this one over here. this line now becomes less than 90 degrees. It's like showing up like 75. Okay, I hope you saw that.
Yeah,
I did. See that okay,
yeah,
Ryan?
I zoomed in.
Okay, guys, that's all there is to that. All the angles on the acute triangle are acute. Every one of them. The right angle, you're just looking for one right angle, and you'll know that right away because it's two perpendicular lines, right? 90 degrees. Now this one, because this is jutting out to the left, not to the right, remember I said there are two sets of numbers on this protractor? Well, if I put this center on the corner of that, now if I want to read these lines, I'm going to see that they're obtuse because they're more. That's like 135 because I'm reading this upper line here. And all you're looking for is just one line that's obtuse. And you can usually tell. You see how extreme that is? That just doesn't want. There we go. See how extreme that angle is? That's obtuse. And it's quite different from the acute angles and everything. Acute angles look like they're chewing, they're going to come together, slowly come together. These look like you're opening it up more. So just remember those, read the explanations in the book. If you forget, go back into the chapter and read it. And that's all I can tell you about that. If you have any questions, you know you can text me. I gave you my phone number, sadly. And don't abuse that. Don't tell I already told your parents, don't let you abuse that. But you can email me or text me or whatever. Okay, Rise, we're going to take a break and I'm going to look at chapter 121.